Welcome. I'm going to run through the process of creating the solution for the Rubik's Cube Search first assignment. I've already cloned my repository and did the initial build on it, so everything's built. I just need to do the process of making the program, the Rubik's Cube solver, actually be able to do searches. Over here I'm going to, I'm in my root of my Git repository. I'm going to, in the top window, go ahead and move into the run area for the optimal builds so I can run the Rubik's Cube solver. Just want to demonstrate here. If I say init cube solved, shuffle it, say 3 times, show the cube, we can see that it's shuffled and it's a goal to be solved, and then do a search. Let's see, we config the depth limit to be 3, and then search tree depth limited, and I get the fact that I must search, I must implement the search function in order for it to work. So that's what we're going to do right now. So over here in my editor, I'm going to go ahead into the program area, and realizing that I'm supposed to be copying a bunch of code from the rectangle and modifying it for the Rubik's Cube, I'll go into the rectangle project. Let's see, I want the action class, I want the problem class, I want the state class. I'm just going to copy them over to my Rubik's Cube area. Go over to Rubik's Cube. Now we've got all these rectangle classes. Let's go ahead and replace those. I want to get rid of rectangle and replace it with cube. Okay, and then let's go ahead and edit those one at a time. I'll start with the action. In here I want to change my headers so they refer to the rectangle, the cube action instead of the rectangle action, and I want the cube model to be included, not the rectangle model. Change my namespace over to Rubiks, which matches with everything else that existed, and realizing that the cube model already defines a class called move, this part of the code should be fine. Okay, go into the CPP file. Replace rectangle references with cube related references, fix up the namespace, and the biggest thing I'm going to run into here is that the Rubik's Cube move class does not have a display string method. So let me go back into the model class because I can't remember what its display looks like. So I'm looking at the move class in cube model. Let me see, I've got, here's a method right here called getName. This should give me a textual representation of the move. That looks like the thing I want. So I'm going to go ahead and replace display string with getName. And I think I'll need to do that down here as well in the overloaded output operator. Okay. So I believe that should be sufficient to get me started with the action class. I'm going to jump to the state class next because it's also relatively simple to substitute in. It's just a wrapper, just like the action class is. Oop. Alright, let me fix up the namespace there. Now, if I were to look in the cube model class, I would see, or the cube model file, I'd see there's no class called model, but there is a class called cube, which is the model we're dealing with here. So whenever the model class is referred to, I want to replace its reference with, or its mention with the cube class. I'm going to leave the name of the method still called getModel and leave my data member called model as well. Okay, so all I've done is replace any references to rectangle with a cube related reference instead, but the structure of this class should stay the same layout. I'll go ahead and move into the cube state CPP file, repeat my process, update the namespace and the includes. Let's go replace the model class. There's another instance and there's another one. Okay. Alright, now I'm going to go ahead and do a manual scan of the rest of the code to see what else needs to do. I'm going to initialize my cube model from another cube model, fine. Copy constructor looks fine. The display method. The cube class doesn't have a display string method. Let's see what kinds of display methods it has. Down here. I'm going to go ahead and do the one word display version here, which takes a stream as its input in order to send the cube's display to the stream. So I'm going to ask my cube model to one word display itself and pass in standard cout for it to send that stream to, and then I'll close off that line with a standard cout. Sorry, that construction doesn't allow for the output stream. Alright, next down here, the is equal looks like it's straight up. It uses the comparison operator on the cube class, which is fine. Is less than uses the less than operator. That's fine. The is equal and the assignments, those look fine. And the getters also look fine. Oh, need to make the output operator be similar, which in this case should send to the output stream. And I don't think there's a need here to send an extra endl. Okay, good deal. I think the cube state should be at least ready for its first pass. Cube problem is going to be a little bit more of a interesting issue, so let's go ahead and get started on it. It has a lot more detail. It's not just a wrapper. It's actually got logic associated here. The problem class looks pretty straightforward. Everything's looking good. Okay, so I'll go into the CPP file. Now in the CPP file I might need a little more information, so I'm going to replace rectangle with cube to fix up my header files. Problem state and action, yep, I want all those. And then I want to switch into the correct namespace. Okay, at least for now I'm leaving the problem constructor with its constructor chaining to the AI search problem alone. The goal state. Okay, the Rubik's Cube does not have an isSolved method, but I could relatively quickly create a goal cube and assign solved to make it be a solved cube. And now I'll just check to see if that goal cube is equal to my cube that's stored in my state. Continuing on, there's a lot of work in here with trying to make sure we got the correct rectangle. I'm going to reduce that down to only the few things that we actually need here. So I want to do all the 12 default actions. What I'm going to do with that then is I can create a move that is the up move and push that action back. And then if I wanted to, I could continue do up prime and so forth and do that 12 times. I choose to be just a little bit lazier. I'm going to write a for loop and let I start off to be the first move that I want to loop over, and as long as I is less than or equal to the last move, which I believe is MDP, I can loop over all of the basic move identifiers, and then when I construct my move I can put I down here. Only problem is the compiler won't be happy with an integer where a basic move is required, so I'm going to do a static cast into basic move that identifier. Oop, get that balanced. Okay. So that should be able to create all my actions. The result class, or the result method now, is actually responsible for creating the new model. So what I'm going to do is copy the model, which is actually not a model, is it? It's a cube, from the existing state, then tell that model to apply move, the move that we have, and the cube apply move expects the source model as the second parameter, the cube that's going to be modified. Okay. So I create a model. In fact, you know, I don't even need to initialize it. I can just create it like so. Then apply a move to it, which will completely replace the contents of model with the results of the current state's model and the move from the action being applied. I'll create a new state and return it. Alright, finally I need to do step cost, and I'm not sure, I don't remember for sure what the name of the cost method is. It's get cost with the lower g. Isn't that convenient? Okay, cool. So the cube problem class, I've at least got an implementation of it. And now I still actually have to do the search functions, but I just want to try to see if I got any syntax errors, because I think that I've written the action state and problem classes. They should at least be syntactically correct. So over here in the bottom right window, I'm going to move into the AI agent build area specifically for the Rubiks cube, and issue a make down there, so I don't have to watch all the makes go by. I can just watch the ones I care about. Alright, so looks like I've got a few syntax errors. Let's go ahead and see if we can straighten those out. So as you notice, I scrolled back to the beginning of my build process and look at the first compiler error. And the first one that comes out is AI rectangle state is being used. Obviously I don't want that to be used in my Rubik's cube, and I'm talking about cube state.h line 34. Oh, we're right there. Yeah, that would have been a problem for me. I'm just going to search for rectangle elsewhere. Looks like the cube action had the same issue. Let me see if I've got any of the CPP files. I do. Let's fix those guys up as well. Namespaces are great for isolation, just got to use them correctly. Okay, so at least lowercase rectangle's been removed from my source code. Let me clear this screen and run make again. See what kind of errors we still have remaining. Okay, got a little bit further. Next error is in cube state CPP line 56. M model was not declared in this scope. M model under display. Okay, so this is cube state CPP. Oh, I'm in that file. Line 56. Well, obviously M model isn't there. I'm not inside of the method, am I? So I would have to say state.get model one word display. That makes perfect sense. So let me clear the screen and do a make again. Looks like we're getting closer. I'm being told that in cube problem line 32, okay, basic move is actually an enumeration that was built inside of the move class itself, so I need to include the correct scoping for it in the same way I did for the items that are enumerated inside of the basic move. Okay, another build. Finally, I'm being told that RS1 is not used inside of cube problems. Which method is this? Cube problems actions. Okay, and I'm actually not using the input state because all actions are always available. I'm just going to comment that out for now rather than actually delete it. Okay, so my program built. Now that doesn't mean that I can actually do a search yet because I haven't implemented the search functions. It just means I don't have any syntax errors in my initial implementation of all of the search support classes. Next, I'll go ahead and fill in my cube search functions. So really what I need is, the search function is correct, but I need search aux and everything it depends on to be filled in. Now rather than copying the rectangle, all the file, since there's already some infrastructure here, I'm going to go to rectangles search, and I'm going to start from right inside the namespace and go all the way down except for the search function. Copy, come in here, boom, and paste. Okay, so now I've got all this rectangle related code. I just need to go and audit it and fix the stuff that's rectangle related and make it into cube related. Let's see, I'm getting a bunch of messages. Let me include AI search.h here, see if that helps get rid of some of those warnings. Okay, the create search frontier's purpose is to create a frontier based off of the keyword that the user used when they said what style of frontier they wanted. So here we recognize A star, BFS, DFS, and so forth. All of this code is specific to the search library itself, not specific to the problem at hand, so I don't expect any changes required. Next is create the search algorithm. This just chooses between tree and graph. Again, this is not really dependent upon the problem at hand because tree and graph are just algorithms already written inside the AI search library. I will point out that we pull generation limit and storage limit from the app data in order to configure the algorithm. Search init is responsible for constructing my initial state, my initial problem, selecting a frontier and an algorithm. So here we go, it's all stacked up. So data.model is looking into app data, but inside of app data, the class, cube app data, you'll see there is no model, but there is a cube. So instead of saying data.model, I need to say data.cube. That will construct my initial state. I'll follow that up with constructing a problem initializing from that initial state. The frontier will be selected based off of the user's selection when they typed into search, and the same for the search algorithm. So those just come from above. And you'll notice that the algorithm creation uses the problem that was constructed here, and it uses the frontier that was constructed there in order to fill in the actual algorithm. So the problem is referred to it, and it refers to the initial state. All that information up above is recorded in the algorithm itself. Okay, so search aux, here's the big workhorse. It checks to see what the iterative deepening limit is if we're doing iterative deepening search. It then records a bunch of data. Most of this data is actually for reporting out the result when the search is finished. If we've configured it, we want machine friendly output, then we give one type of output to the machine stream here. Okay. So I'm looking again for anything that is specific to rectangle that needs to be changed. Okay, the iterative deepening search is not specific to rectangle, it's generic search. The algorithm is initialized here if we're doing a search. If we want to do a human output, we'll do that there. Okay, here is the actual request to search our tree or graph. It will return true if a goal was found, that is if goal test ever said true, and it will return false if the queue becomes empty or storage or generation limit is reached and a goal is not found. Okay, some more display output, but notice that if we're inside of this if statement that the search has succeeded. So what we'll do is ask the algorithm to give us a list of all of the action state pairs that were necessary to go from the initial state to a goal state. And then this loops over all of them, all of those action state pairs. So the action state pair will first grab the action, and we have to check to make sure there actually is an action because the initial state is also in this list and it doesn't have an action because there was no action to reach it. But if we have an action, then we want to convert to a Rubiks action object with a dynamic cast. And then we would like to take the textual representation of that action and save it into this moves stream. Now if we're supposed to apply the solution, then we should apply it here, and we want data.cube to be the result of applying action get move to the current state of the data.cube, right? But in order to avoid some memory write over errors, we need to make a temporary cube that's a copy of that cube to pass as our parameter to apply move. Apply move does not return true or false like it did with rectangle, so it's not possible for it to tell us that the move was not allowed. It is allowed. Okay, we'll add up our total cost. We're not displaying any of the states as we go along, so we won't worry about that. Okay, coming down, begin scanning for anything that's rectangle specific that needs a change for the cube, and all of this is just calculating how much work has been done and giving reports back to the users. Let me see here. This is specific. So for the command line interaction, rotate is the keyword for a move, whereas place is for rectangle. That same thing would go here. Okay. I think that's a basic outline. Maybe I've caught it all. Let's find out. Come over here, try to do a make again. Okay, we got a few errors. Let's start with the first one. Somehow I still left some rectangles in here. Okay, got rid of those. What's next? Okay, Rubik's cube search line 61. Says it doesn't know about Rubik's state. Well, whose fault is that? That would be mine. So I should include cube action, state, and problem up here. Yep. Getting a little bit closer. It's saying it doesn't know what a string stream is. That's because I included IO stream. If I didn't include S stream. Okay, so now I don't know if it's going to work or not, but I've got a compiled executable that has an implemented search function, and I want to see if it's going to work or not. So my basic operation would be to relaunch the solver, and I'm just going to reissue the similar commands that I had before. So I see a somewhat shuffled cube. Make sure that my goal is a solved cube. Configure my depth limit to 3 and try to do a depth limited search. Okay, after I do my depth limited search, we found a solution with 3 moves, U, L prime, D prime. Cost was 3, 49 nodes generated, and 34 is the maximum frontier size. Okay, so I'm actually doing some search. So that should be sufficient to be a solution for this first week's assignment for programming with the Rubik's Cube. I'm going to leave this directory right here and just see if my verifier works or not. So I'm going to go back to the source code directory. Let's see, AI agents, right? And prog Rubik's Cube. I'm going to go into the verifier directory. And run verify many. See that it goes ahead and cranks through up through depth 4, solving them fairly quickly, less than a second to solve 10, 6 seconds for 10 at the depth 5. And I'm expecting it to be more like a minute or two to solve the depth 6 ones, but it's actually solving them. So this is at least, again, a sanity check that it looks like it's kind of working, at least enough to assume I can do some searches. All right, thank you. Let's see, how long was that? Looks like it took me 27 minutes. Thanks.